LORD MicroStrain inertial sensors that include magnetometers are factory calibrated to provide optimum magnetic field accuracy. However, factory calibration cannot correct for errors influenced by external magnetic sources. External magnetic influences are divided into two classes: hard iron offsets and soft iron distortions. Hard iron offsets are created by objects that produce a magnetic field. Soft iron distortions are considered deflections or alterations in the existing magnetic field. External magnetic influences can be mitigated by installing the sensor as far from any ferrous materials or magnetic sources as possible. As electromechanical systems are often largely composed of ferrous materials and magnetic sources, in reality this can be difficult to achieve. To compensate, after installation, users should perform a field calibration of the magnetometer. The LORD MicroStrain MIP Iron calibration software is designed for this purpose. This software is available on the flash drive included with your sensor and online at www.microstrain.com under the Documentation tab for any 3DM GX4 product. After installation of the MIP software suite and all necessary drivers onto a computer running a Windows 64-bit operating system, navigate to the software execution icon, Start, All Programs, MicroStrain, MIP Iron Calibration, and open the program. For reference, from now on, we'll refer to this software as simply the Iron Cal software. Begin by making sure your computer has a working connection to the internet, and select the WMM on Web button. It is located in the Local Magnetic Field Parameters section of the UI, UI being short for User Interface. This should launch your default browser, or open a new page if you already have one open. The page that it arrives at is the World Magnetic Model Calculator provided by the British Geological Survey. The address is also on a link in the below description. Use your mouse to left-click and drag the map to the rough area of your location, and then zoom in and continue to navigate the view until you can clearly see where you are located. Then click on the location and select the Save button in the informational box that pops up pointing to your location. As an alternative, there are plenty of sites on the web that can assist you by allowing you to type in your address and generate a numerical value of your latitude and longitude. We'll provide another link below for one such site. Now, copy the value in row MV, column F, and paste it into the text box to the right of local magnitude F in the Local Magnetic Field Parameters section of the Iron Cal software UI. Then copy the value in the row MF, column I field, and paste it into the text box to the right of local inclination I. This will ensure that your final calculation values reflect the influence of Earth's magnetic field in your local area. Next, connect the GX4 sensor to the computer. Once the device is powered up and is in communication with your computer, indicated by the LED blinking green, select the Refresh Device List button next to the device list pane in the Iron Cal software UI. Your connected device should now appear in the device list pane. Left-click the device name to select it as the unit you wish to calibrate. Next, we'll begin gathering data. Note that for this demonstration, we'll be collecting data with the device strapped down to a platform that does not contain any ferrous materials. This means that the resulting shape of our plot will be spherical. If your platform does contain ferrous materials, it will likely end up offset and possibly appear oblong or ellipsoidal. To ensure that the plot is not distorted while collecting data, be sure to keep the device platform as far as possible from any external ferrous materials or other magnetic influences. Select the Start Collecting Calibration Data button, which looks like a red Record button, located below the device list pane. This will begin collecting data from the magnetometers, identifying any local platform magnetism that may be influencing sensor readings. As the software collects data, rotate the sensor or sensor platform in all possible axes. Collected data points will appear in the graph in red. The aim is to fill in as many areas as possible, gathering data points from all directions that a magnetic influence may derive from. The max number of points is 1000, but 100 or more points is usually enough to generate a proper cal. Note that to simulate actual use, ground vehicles and other platforms restricted to certain axes of movement should be moved with as much variance in direction as possible. Care should be taken to avoid excessive magnetic sources. You're attempting to get a baseline value of the platform's magnetic influences in a neutral environment. Once you have enough data points, select the Stop Collecting Data button next to the Start Collecting Calibration Data button, and then select the Save Data button within the Data File portion of the UI window. Depending upon your application or platform, you will need to select the type of fit that best represents your calibration requirements, and then select the Write Fit button for that fit. This will write the fit data to the GX4 device's internal memory. The two options, spherical fit and ellipsoidal fit, can be chosen from the respective tabs in the center right of the UI, next to the default Open tab labeled Current Cal. Spherical fit is often best for applications that are restricted in rotational axes, like a ground vehicle, surface watercraft, or railway vehicle. The ellipsoidal fit is usually beneficial when soft iron influences are a factor, though only if enough data points can be collected in all axes. Similarly, platforms that are not very restricted and can orient themselves in most or all axes will often find the ellipsoidal fit beneficial. If the spherical and ellipsoidal fits are close in their mean diameters, ellipsoidal will usually be beneficial to a successful calibration. Once the write-to-device memory is completed, usually it should be finished in a matter of seconds, select the Plot Calibrated Magnetic Field Data button, which looks like a play button, within the Verify Calibration section of the UI. Now repeat Step 6, rotating the device in as many axes as possible. The data points for the verification process will show up in green. When you've stopped collecting verification data points, select the Stop Verifying Data button within the Verify Calibration section of the UI. Now, observe the green calibration plot as it relates to the green gridded shape in the same graphical data plotting pane of the UI. The majority of dots should lie on or just off the surface of the gridded shape. You can left-click within the left-handed graphical data plotting pane and move your mouse while holding down the button to rotate around the plots. You can also zoom in and out by rotating your mouse wheel forward and back. If they are well matched, the calibration is a success. If not, you may need to alter your methodology in gathering rotational data and/or selecting the best fit for your application, meaning that another calibration cycle may be necessary. For more information, go to www.microstrain.com or contact our award-winning support department at www.microstrain.com/support.